Good morning, Year 4. Welcome to Maths for Monday, the 8th of February. Today we are going to be looking at those pesky equivalent fractions again, seeing if we can get our heads around those a little bit more. So, without further ado, that's not what you need to see. Try again, Mrs. Eggleshaw. You want your warm-up. I know you'd be very upset if you missed that. So there we go. Your warm-up today, counting backwards through 0 to include negative numbers. Okay, so there's some negative numbers here. Pause here and see if you can fill in the gaps on these missing number sequences, please. Off you go. Okay, I'm just going to move on to the answers, which are there. It's a little bit bigger for you, because I know some of you are looking on really teensy screens. There we go. Okay, have a little check of those. Just look at the first one together, and then you can just look at the rest yourselves. So 3, 2, 1, 0, and then we go into minus numbers, into negative numbers. -1, -2, -3, -4, -5, -6. And then this one, 20, 10, so this one's going in tens, isn't it? 20, 10, 0, so that's -10, -20, and so on. And you can have a look at the rest yourself and pause here until you've done that. Okay, moving on to today's lesson. We're going to be looking at equivalent fractions again. This is lesson 2 of equivalent fractions. The number line represents one whole. Where can we see the fraction? Can we see any equivalent fractions? Okay, so here, this bar here, the purple bar, is representing one whole. And what I'd like you to do is to pause and see if you can work out what fraction the white bar is showing. Okay, so one piece of that. Okay, so this fraction here, this much of that bar. And then this one, again, the purple one's showing a whole. And then whereabouts this fraction here, what is that representing? What fraction of the bar is that fraction representing, and so on and so forth. So if you could just pause here, have a little look at that. Okay, so hopefully you realise that there are 2 equal pieces here, 1, 2. The white bar is divided into 2 equal pieces, and we're talking about one of those pieces, aren't we? Because we're only halfway along. If we're in the middle, we're halfway along, so that bar there is what we're talking about, so 1 out of 2. So imagine a little car driving down the road, it's done 1 out of the 2 pieces, hasn't it? And then this one here, these are chopped into quarters, aren't they? It's sort of, you've got some dotted lines there to give you a little bit of a hint. So they're chopped into pieces of 4, into 4 equal pieces. So we'll have 4s on the bottom. And then we need to think about how many we've got. So if we imagine our little imaginary car again, driving along, when it gets to here, it's driven along past 1 of the pieces. So we'll pop a 1 in there, that's 1/4. And then when it gets to this one, it's driven past 2 pieces. And then when it gets to this one, it's done 1, 2, 3 pieces. So we'll pop 3 in there. Okay. So we've got 1/4 and we've got 2 quarters and we've got 3 quarters. Now, some of you might have already spotted that we could also have put here 1/2, because as we said before, we can halves, equivalents of halves are really super easy, because the top number is always half of the bottom number, and so 2 is half of 4. So 2 quarters is equivalent, is the same as a half. Okay. So we can see those moving along there. On this one, we have to complete the missing equivalent fractions. Okay, so they're in eighths along the top here. And on the bottom here, these are broken into 4 equal pieces. So if we broke it here where these are, look, it'd be 1 piece. It's hard to show you when I can't point to the screen. 1 piece here, 2, 3, 4. Okay, so there's they're broken up into 4 equal pieces. Okay, so I'm going to put 4s in the bottom again. We can do this one together, you don't need to pause. I'm going to put 4s in the bottom again. Or I could say this one was half again, couldn't I? If I wanted to, because that is right as well. And then this is 1/4, because we've only travelled one, it's only got one of the pieces. This is 2/4, and this one is 3/4 again. And if you have a look at those, you can see that 2/8 is equivalent to 1/4. And if we put those side by side, we can see that 4 times 2 is 8, and 1 times 2 is 2. So that's going back to what we talked about yesterday, Friday, in fact, about multiplying the top and the bottom by the same number. And then the same at the bottom here with the 3/4. We can see an equivalent fraction is 6/8 there, because 4 times 2 is 8 and 3 times 2 is 6. Okay, and if we were to chop this shape up here, it's currently chopped into 8 squares and 6 of them are coloured in. If we chopped them into 4 squares, then there would be 3 of them, 3 of the columns. If we chop them into sort of 4 columns, there'd be 3 of those columns coloured in. Okay. This is sometimes quite useful for showing you equivalent fractions, because you can just kind of draw the line down. So here you can quite clearly see that 2/8 is the same as 1/4, and 2/4 is the same as a half, and 4/4 is the same as a half as well. And you can Google a whole fraction more with all the different fractions on. It can be very useful. So up to you again now. So you're going to have a little try first. You have to place the equivalent fractions on the number line. Now, I don't expect you to draw out the number line perfectly, but if you could just put, just write the fractions out in order, so 1/12, 2/12, 3/12, maybe use 2 squares for each one on your book, and then just match these equivalent fractions. Where do they go? What do they go with? And think about, what do you need to times the top and the bottom by? Okay, for them to go together. All right, so pause here and have a little try, see if you can work out where you think they might go, and then we'll come back together and have a go together in a minute. Okay, so let's have a little look together. I'm going to start off, I'm going to get my pen and I'm going to mark halfway on the number line. Okay, so this is my halfway line. I haven't got one up here that says half, but I just want to mark that so that I know that that's halfway, because if I then look halfway again, that's going to help me with where my quarter goes, because I know that 2/4 make up a half. So if I look in between and I find the middle line, this one is going to be the quarter one. Okay, so that's my quarter line. So I'm going to move that fraction there, and then I'm going to have a look at it with the other one, and I'm going to think to myself, right, what if I put, oh, can't put them next to each other. What do I do to get, how many 4s make 12? And I know that 3 4s make 12. 3 times 4 is 12, or 4 times 3 is 12. And 1 times 3 is 3. So I know that that one's equivalent, and I know that it is in the correct space. Okay, and then the next one I'm going to look at is 3/4, because I'm just done quarters on the other page, and so they're nice and fresh in my mind. And I'm going to put halfway between the half line and 1. I know I'm going to find 3/4. Okay, so it's going to be 1/4 of the way. So now I've broken my number line up, haven't I, into quarters. Can you see? So I've got 4 equal chunks. There's 1 chunk, there's 2 chunks, there's 3 chunks, and 4 chunks, and they're 4 equal chunks. And it's really important that they're equal. Now, if I put my 3/4 there, I can have a look and check that these two are pairs of fractions that go together. So 4 times 3 is 12. I just worked that out before. And 3 times 3 is 9. Yes, so they go together, so that's great. Okay, the next one that I'm going to have a look at is my 6. Now, how do I get from 6 to 12? That's what I want to think about. How would I get, what do I need to multiply by? Because these are all 12ths, aren't they, on the bottom? So what do I need to multiply 6 by to get to 12? And the answer is 2, isn't it? I need to do 6 times 2 would get me to 12. So I know that this one goes on to 12ths because 6 times 2 is 12 and 1 times 2 is 2. So that gave me that answer, and I can do something similar with these. What do I need? Let's do 1/3 first because that one's a little bit easier. What do I need? 3 times what makes 12? Well, I know, because we've said it several times already on this, that 3 times 4 makes 12. So I'm going to sort of hesitantly put it there, and then I'm going to check. 3 times 4 makes 12, and I chose to put it there because there's a 4 there. Okay, so 3 times 4 makes 12, and then 1 times 3 times 4 makes 12, and then 1 times 4 makes 4. So I know that that one is in the correct place. Now then, this one here is double, isn't it? This one. So the top number is double. So because that's a 4 and I want double that amount, I'm going to put it over here. And if I was to break this, get a different colour pen a minute. If I was to break this number line up into thirds, into equal pieces of 3, I'd put, oh, no, I wouldn't do that. I would put, get my pen, and I would put a line there and a line there, and that would chop it into 3 equal pieces, wouldn't it? So that's 1/3 there, and then I've put my 2/3 on that line there. And I can check, if I can just move that out of the way a little bit, I can check that those two go together because 3 times 4 makes 12 and 2 times 4 makes 8. Now, if I put this in the wrong place, and I did, right, 3 times 4 makes 12, 2 times 4, 2 times 4 makes 8. So that's not going to have to go there, it's going to have to go there. Okay, so I can use that multiplication rule that I know to make sure that I've got them in the right place. It's quite a tricky task. So are there any other equivalent fractions you can identify on the number line? You may have had a look at that and found some. Obviously, there's lots that you can do for half. Basically, you can take any one of those and just do the same to the top as you do to the bottom, and then you've got an equivalent fraction. So if we wanted to do any of them, it doesn't really matter. Maybe we'll take this one, 1/3, and we might decide that we're going to multiply this one by 3. So we're going to say, right, 3 times 3 is 9, and 1 times 3 is 3. So I've made myself another equivalent fraction there. Okay, I'm going to put it up there so that I'm quite sure that that's quite clear, should I say, that that's in the right place. It doesn't want me to pick it up. Come on. There we go. Okay, so I could have done that with any of these. I could have taken this one and I could have done 2 times 2 is 4 and 3 times 2 is 6. So I could write that as well. Say, right, 2 times, I'm going to times this one by 2. 2 times 2 is 4. 3 times 2 is 6. So therefore, that one, 4/6 is another equivalent fraction to go with those. Okay, so it's actually quite straightforward. When they say find any equivalent fraction, you just pick any one and times them both by the same thing. You could even pick this one here. You could times each of those by 2 if you wanted to. You could say, right, okay, I always start off times them by 2 because it's easier. You could times it by whatever number you want, really. But I could do 11 times 2 is 22, and 12 times 2 is 24. And there you go, 22 24ths is an equivalent fraction to 11 12ths. Okay, so let's move on. Alex and Tommy are using number lines to explore equivalent fractions. Alex says 2/6 is equal to 1/3. She's drawn some number lines to represent that. And Tommy says 3/6 are equal to 1/3. Who do you agree with? Explain why. So can you pause here and have a little look, write down who you agree with and why. We'll come back together in a second. Okay, so I'm hoping that you noticed, you might have done 2 things. First of all, you might have just noticed and said, hang on a minute, Tommy, your number lines are not in equal, you haven't drawn those equally. Look at all his lines are all over the place, aren't they? They're not equal sections, are they, on a number line? He's got some bigger bits here and some smaller bits here, so that one's not equal. So he might have said Tommy's wrong because his number line is not divided into equal pieces, and that's really important when we're talking about fractions. Another way that you might have checked, you might have just said, well, hang on, it can't work because the numbers don't work. If we look at Alex, let's check her numbers. 3 times what makes 6? Well, 3 times 2 makes 6. So if she's correct, then the top numbers should be times 2 as well. So 3 times 2 is 6. 1 times 2 is 2. So her numbers make sense. If we look at Tommy's numbers, 3 times 6. How do we get from 3 to 6? We do times 2. So 3 times 2 is 6. But 1 times 2 isn't 3, is it? So that would be times 3. And that can't be right, because if you remember, when we look on our steps to success, we have to do the same to the top as we do to the bottom. Okay, they've got to be multiplied by the same amount to find equivalent fractions. If the numerator and denominator have been multiplied by differing amounts, which is what Tommy's done, they are not equivalent. Okay, so Tommy is incorrect. Okay, so we can see in 2 ways. You might have just noticed that his number line was off. So Alex is correct. Tommy's number line isn't split into equal parts, which means he cannot find the correct fraction, and we can see from our numbers that he's definitely not done that. So your task for today, we've got silver and gold on the same page today because you need the same sheet for them. And I've made it as giant as I can. You need to fill in these equivalent fractions. I've put this here to help you. It may help you or it may just confuse you. Sometimes diagrams like that confuse me and sometimes they help. So just ignore it if it doesn't. You need to find the equivalent fraction. So work out what has been done to the number. So for the first one, for example, we would say 2 times what makes 6? 2 times 3 makes 6. So if it's 2 times 3 to make 6, you need to do 1 times 3, and that will tell you that 3 goes in the top box. Okay, so that's the first part. That's silver. Okay, it's finding those equivalent fractions and they're numbered, so you can just write them out in your book. You don't need to draw anything like this out. Then for gold, you need to do silver first, then you need to think of another equivalent fraction for each pair of fractions above. Okay, so do this one and then think of another one that goes with it and write equals and another one. Okay, you can multiply that by any number you like as long as you do the same to the top as you do to the bottom. Just going to move my face out of the way if I can. There we go. So you can see the steps to success, and pause here and have a go at that, and we'll go through the answers together in a minute. Okay, if you've unpaused and you haven't done gold yet, pause again and have a go at gold before we move on to the answers, because otherwise you'll see the answers all at once. Okay, so pause here and do silver and gold, please. Okay, you've pressed go again, so you must be ready now. So I'm just going to flip the page onto here. So I've done these for you. I filled in the things for you. This one, I did 2 times 3, and then I did 1 times 3, and then I just had to do something different to that number, that first fraction. So I decided, because I'd times it by 3 already, I thought now I'm going to do 1 times 2 and 2 times 2, and I got 2 quarters. Or I might have done something different to that one. I could have done 3 times 2 and got 6, and 6 times 2 and got 12. So it's any equivalent fraction. That's not the only equivalent fraction you can have. Here I did 3 times 2 was 6, 2 times 2 was 4 to get that answer. And then I took that fraction, I decided to times it by 2 again. So I did 4 times 2 was 8, and 6 times 2 was 12. But you could have done anything. You could have times it by 4, 5, whatever you wanted to. Okay. And then you can just look at the rest of the answers yourself. Any equivalent fraction will be correct for gold. I haven't clearly listed them all because there are hundreds of them, but you need to make sure that you've done the same to the top as you did to the bottom. And it doesn't matter if you do it to this fraction or this fraction, just choose one of the fractions and multiply or divide it by the same number top and bottom, and you will have an equivalent fraction. Okay, if you're not sure, then you can send me a little picture on Dojo, try and get a nice close-up picture, and I can check them if you aren't sure yourself. Okay, right, and then we can move on, if you're being brave, to platinum. So here's the platinum task. I'll leave you to read it through yourself and pause it and have a go, and then you can press play again when you're ready, when you think you're done, and I'll show you the answers. Okay, so the answers are here. I'm not going to go all through all of this because it'll take a really long time, and I know that not everybody does platinum anyway, so you can pause it here and have a little look. I will draw your attention to this bit at the bottom, accept other correct equivalences. So it doesn't matter for this one, the circle, for example, is half. It doesn't matter if you put 4/8 or 6/12 or whatever, as long as it's equivalent to half, then that's absolutely fine. Equivalent to 2/3 or whatever, whichever one you're looking at. Okay, well done if you did have a go at that, because it was a really tricky lesson today. So good for you for persevering if you tried to get to platinum as well. Right, that's the end of Monday's maths lesson. We will be back for a third lesson of equivalent fractions tomorrow. And hopefully it's getting a bit easier each time for you to understand what we're trying to do. Okay, so have a lovely evening, and I will see you tomorrow.